I want to work through solving some trig equations here. And so I want to show a couple different ways what we're looking for, how we're getting there. So I'm going to do 22 and 23 here on this review, okay? So on 22, the first thing we want to do is we want to start by getting the tangent x by itself. I'm going to do that by adding the square root of 3 to the other side. And now, when I get here, I've got this tangent by itself. I'm trying to figure out what value of x, what degree or radian measurement has a tangent that is a square root of 3. So I'm going to go back to my special right triangles, and I'm going to look for which one has a tangent that is equal to square root of 3. And I can see that pi over 3 has a tangent that is the square root of 3. Now notice this is saying for all values. That means that we have to do a couple things. First of all, we have to find all of the values within the quadrants, and then we have to find all of the values that are going to repeat, which means we need to know the period. Tangent has a period of pi. So I am really solving for all of the values between 0 and pi, because anything after pi is going to be a repeat of the values that are between 0 and pi. Pi over 3 is in my first quadrant. If I look at my second quadrant, tangent is not positive in the second quadrant, so I cannot have a positive square root of 3 there. So I only have this one answer, pi over 3. However, I have to include my repeating part, which in this case, because the period is pi, this repeats n pi times. Don't forget to pay attention to that when you're solving. Are you solving for all values, or are you restricting yourself like I'm going to do on 23? Make sure you're paying attention to that so you write your answer correctly and you include that repeater value, or don't include it if you don't need to, okay? Let's look at number 23. We want to try to solve this. We want to, most often with trig equations, get them equal to 0. That's going to tell us where we need to go. Excuse me. So I'm going to subtract the 8 secant x from the 3 secant x, and I'm going to get negative 5 secant x minus 10 equals 0. Now from here, I want to try to get the secant by itself. I'm going to do that first by adding 10, and then I'm going to divide by negative 5, which 10 over negative 5 is negative 2. So I'm looking for where is the secant of x equal to negative 2. Again, I want to go back to my triangles. I know secant goes with cosine, so I'm really looking for where is cosine 1/2. And that would be at a pi over 3 angle. But because it's negative, I have to think about which pi over 3 values have a negative cosine. I'm going to go back to my quadrants. I know that in the first quadrant, all the trig functions are positive. In the second quadrant, it's sine. Third is tangent. Fourth is cosine. So the question is, where is cosine? Because secant goes with cosine. Where is cosine negative? That would be in quadrants 2 and 3. So I'm looking for the pi over 3 value that's in quadrant 2 and in quadrant 3. The one that is in quadrant 2 would be 2 pi over 3. And the one that is in quadrant, the pi over 3 value that is in quadrant 3 would be, it's going to be over pi, so it's going to be 4 pi over 3, okay? Again, you can use that chart that I gave you. That's kind of helpful with all of those from the unit circle. But it really is helpful to know which quadrants are positive and which quadrants are negative for which trig function so that you know where you're looking. Now notice I did not have to put the n pi or 2 pi n repeating value because I have restricted my solution set to everything between 0 and 2 pi, meaning that I don't have to worry about whether or not it's repeating because I'm just looking in those first four quadrants, okay? So hopefully this kind of helps with the solving. I just wanted to go over again how to do it, what the process is, getting it equal to 0, get the trig function by itself, then figure out which values, which radian measures, make those true, making sure that they are in the correct quadrants as well. And knowing what trig functions are positive in which quadrants is extremely helpful here, okay? So make sure that you have that information handy so that you can easily solve a trig equation.